So now let's take a look at question 5, and this one states, if the series summation of Cn times 6n is convergent, then the summation, I think there's an extra space there, then the summation or the series Cn times negative 6 to the power of n is convergent. Alright, so let's take a look at the solution, and this is in fact false, and let's go over this. So note that the radius of convergence theorem doesn't help us, so we can't look at this and get some useful info from it, and we can take a look at that. So let's do that same stuff that we did before. So let's say we had the summation of Cn, and then this is going to be 6n. Or so now it's 6n. We already went over that one, so let's put the negative 6 to the power of n like that, and write this in the power series form. This is going to be Cn and then x minus a power of n. So in this case we have, let's put this like this. X is equal to negative 6 in our case, and then a is equal to 0. Alright, so we have the three cases now. So we have converges for either, so I'll just put that for completeness, this sentence there. So for either, if we have I, so if we have x equals to a, in our case, x is not equal to a, and that's because we have x is equal to negative 6. So we have negative 6 is not equal to 0, where that is a over there. So then the other scenario could be, alright, so the second case, this is for, well, all x. I'll just put all x. So it's either all x. Yeah, so if this is the case, then it would be convergent, but we don't know that. And then we have the other case. It could also be this one here, where we have absolute value of x minus a is this equals 2. The number has to be less than r, the radius of convergence. And in our case, it's equals to negative 6 minus 0. This just equals to absolute value of negative 6, which equals 6 less than r. Like that. And now this scenario right here is the same as for the other case, for the 6n, 6 to the power of n, if I scroll up here. So this is the same thing. We have, so it's either for all x or for 6 is less than r, so it's in one of these scenarios. So it's basically saying, yeah, that either converges for all x, or for this scenario where 6, this right here is less than r, but we don't know that. Yeah, we don't know what this value of r is. This one could be, for example, if it was 7. So if it was 7, then this would be convergent. But it could be 6. So let's say if r is 6, then that's going to be at the endpoint, and we don't know if this will be convergent. Whereas this one, we're given that it's convergent here. Yeah, so we're given that this is convergent. So it could be that just at the endpoint of this x equals 6 is convergent. But then now we're looking at x equals negative 6, so we can't tell that. Yeah, so we could go scroll this here. So we could write same as for the other series, the Cn and then 6 to the 6, Cn to the 6 to the n. Yeah, but r could be 6, but r, yeah, but right here. So, but if r equals to 6, then, or here I just quickly erased that and wrote instead, just because we could write more just quickly and so on. So this doesn't help us, because if r of the radius of convergence equals to 6, then the series could converge at x equals 6, but not at x equals to negative 6. So in other words, the radius of convergence doesn't help us at the endpoints. Alright, so instead we can modify both series as follows. And to do this, we could just pick a value for the constant. So let, I'll write this here, let c sub n equals 2, so the coefficients there, negative 1 to the power of n over n to the 6n, like that. So if we have let this, then what we'll have is, then if we have the summation the one that we're given, that's converges, so cn times 6 to the power of n. This equals 2, and now we're going to replace that in there, and then we can just check if it actually does converge. This is going to be negative 1 to the power of n over n, 6 to the power of n, then times it by 6 to the n, like that. So what happens is, well, this cancels, all we're left with is summation, the negative 1 power of n over n. And here we can check the convergence here. So we can apply the alternating series test. Here's from earlier video. Again, just recap on that, the alternating series test. So if the alternating series, summation from n equals 1 to infinity of negative 1 to the power of n minus 1, bn equals to b1 minus b2 plus b3 minus b4, etc. So alternates, and bn is always positive, greater than 0. And if this satisfies, bn plus 1 is less than or equal to bn, so it's always decreasing for all n, and that the limit as n approaches infinity of bn equals to 0, then the series is convergent. Alright, so let's take a look at our case here. So we have this series, so summation, let's go here, cn 6 to the power of n is equal to, and then this series over there, summation from negative 1 to n, divided by n, like that. Then if you just put this inside, this is gonna be, well, let's start off with n equals 1. So this is n equals to 1 up to infinity, and n equals to 1 up to infinity. Here, just so it matches this part right here. Now if you plug in 1 inside here, this is gonna be negative 1 power of 1. It's gonna be negative 1. And then the next one's going to be, when you put in a 2, it's going to be positive 1 over, and then this one's going to be 2, like that. So initially it's going to be 1 over 1, then 1 over 2, then this is going to be 1 minus, and then this is going to be minus the next one because it's going to be cubed, 1 over 3, and then plus, instead of 1 over 4, and so on. Then it's going to be minus plus. So minus plus dot dot dot. Again, so it's alternating and so on. So this is our b1 is just just equals to 1 there. There's our b2 and so on. And b2 is less than b1 because that's 1 half. 1 divided by 2 is less than 1. Then 1 divided by 3, you're dividing by a bigger number. That's going to be less than the other one there. So then this is our b3 less than b2, etc. So these are all, they all continue on like that. Yeah, so thus what we have is so the series, the alternating series test, thus we have I is this part right here, bn plus 1 is less than or equal to bn. So each one of these is getting smaller and smaller, the bn's there. And that's the alternating setup there. So the bn there, ignore the signs there. And then the next one is limit as n approaches infinity of bn, or b subscript n. This equals to the limit as n approaches infinity of, this is going to be just 1 over n. And then 1 over n, this is just goes to 1 over infinity, approaches 0. So this equals to 0, like that. Yeah, so then this is convergent. Yeah, so I'll just say this is convergent by the alternating series test. Yeah, or actually just write instead over thus the summation of cn 6 to the n, this equals 2. This is going to be negative 1 to the power of n over n. This converges. So this part right here, this is convergent by the alternating series test. And let's just box this in. So that is convergent, just to confirm. This is just the solution manual. They do something like this. So you have this one here, and then that converges. But now this is basically looking at an example of the scenario to show that whether it's true or false, or in this case, looking at if it's false. And we could do the same for the other series we have. Note that, remember, this is going to be false. So we're going to look at all we need is one example where this is not going to be true. So we have Cn like that. So if we do the same for the other series, we have, let's just write that down. So the summation Cn, now we have a negative 6 to the power of n. This equals to and then we're going to replace that with over here. So this Cn equals to negative 1 power of n divided by n times 6n at the bottom. So we have negative 1 power of n over n 6n, and then times it by negative 6 to the power of n. Alright, so what this ends up being is, so now we just simplify this. This is equals to, and let's just write this down, the summation. Now we have negative 1 power of n, and now this one right here, we can simplify this by putting this as a negative 1 power of n, so negative 1n, and now 6 to the n. So just put the n inside the brackets like that. Now this can be divided by n times 6n. So now this cancels, and now these combine. Oh yes, you can combine or add the powers. So then this is going to equal to the summation, and now it's going to be negative 1, 2n. So n plus n is 2n over n. Now this right here, this part right here, this is always equals to 1 because you have a even number there, so 2n. So if you have negative 1 to the power of 3 times 2, that equals negative 1 to the power of 6, and that is equals to 1. So it's always going to be, it's always going to be positive. And or you could even write this down as equaling to, right here is going to be negative 1. So we can put this squared inside. So negative 1 squared, and then this is going to be like that, all to the power of n. So same thing, this one's always going to be positive, equals 1, so this equals to 1n equals to 1. So this means is we're just going to get equals to the harmonic series, 1 over n. Harmonic or p series, this is a divergent series. And this right here is, let's put this in square, this is a p series with p equals 1, which is divergent. And this is divergent. Yeah, so hence we found an example where it is not the case. So it's so that if this is a convergent, this one is divergent, hence the claim is false. Yeah, so box that out.